Hello everybody, my name is Mohit Deshpande, and in this video I want to discuss scalar multiplication, and I actually want to kind of set us up to discuss that. I want to jump right into it, but I want to first give you the motivation for scalar multiplication. So let's first start off by declaring a plain old matrix A, and this time it'll be 3, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 6. So suppose this is our matrix A. I've been trying to use different matrix dimensions each time so that you don't kind of fall into the thinking that, well, matrices are usually this size, or they can really be any size. So let's compute the dimensions of this, so we don't actually have to compute them, we can just look at them. So it says 1, 2, 3, 4 rows and 3 columns. Okay, that's just something interesting to note. But now let's suppose that we wanted to double all the values in A. What could we do with that? Well, if when I double something, that's just the same thing as adding two copies of those things together. And from what we learned about with addition of matrices, we can take two copies of A and add them together. So I can do A plus A, and that has double of A. That takes all the values in A and just adds them to itself. So this 3 is 3 plus 3, which in A plus A the resulting matrix will be 6. Then this is 2, so we just end up doubling all of these values just by taking two copies of A and then adding them together. But now suppose we wanted to increase A by like a factor of 100 or 1,000,000. Well, based on this, what we could do is we could do A plus A plus A plus dot 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 plus A 1,000,000 times, make 1,000,000 copies of A and add them together. And that's really tedious, and that's completely unnecessary. It's a lot of work. But instead of adding 100 copies of A together, why don't we just take each element of A and multiply it individually by 100? And that's exactly what scalar multiplication is. So what we can do is, instead of million, it's going to get too difficult to write. So let me replace million actually with just 100. It's a bit more feasible to write. So instead of making 100 copies of A, we can just take all the entries in A and multiply them by 100 individually. And so this is scalar multiplication. What we do is we have a number here and then a matrix here, and when we multiply them together, what this means is that you take all the elements of A and then multiply them by this outside number here individually. So there's no interdependence, there's no coordinate, because there's only one matrix. So let me actually write out what 100A looks like. So 100A is, let's take all these values and multiply them by 100, right? So 3 becomes 300, 1 becomes 100, 4 becomes 400, 1 is 100 here, then 500 here, then 900 here, and why don't you take a second and complete the rest of, see if you can complete the rest of this matrix. And remember that for scalar multiplication, again, it's also intuitive. You just take each of these, multiply by 100, and everything's in the same position. So why don't you take a second, pause the video, and we will be right back with the answer. Okay, so I left off here, and so this 2 becomes a 200, this 6 becomes 600, 5 becomes 500, 3 is 300, 500, and 600. So this is very intuitive. What we did was just take this 100, or this outside value, it could be anything, and you multiply each one of the elements here by that number outside, and we don't change the position or anything. And actually, this is this exact same as doing 1A times 100. So it doesn't matter the order, as long as one of them is a number and the other is a matrix, we can perform this thing. It's called scalar multiplication. And you might be wondering, well, why is this called scalar multiplication and not number multiplication? Well, that's because individual numbers in the context of something like linear algebra, or they're actually called scalars, because you can kind of think of them as being a matrix of with one row and one column, which is a single value, which is why they're called scalars, but we're not going to talk to anything about that. But that's why it's called scalar multiplication and not something like number multiplication. Now, notice that there's not really any restrictions on this. This number can be really anything, as long as it's a single number and not a matrix. And if you're wondering, yes, there is something called matrix multiplication, where we take two matrices and multiply them together to get a new matrix. That's way more complicated than this simple scalar multiplication, but it's definitely something that exists. So far we've discussed three, well, really two, but I guess technically three matrix operations. That's addition and subtraction, which addition and subtraction are very closely related anyway, and scalar multiplication. And so turns out that these three fundamental matrix operations are really all that we need to discuss some elementary image processing. And we're going to start doing that starting in the next few videos, but let me just recap what we did in this video. We discussed this new kind of matrix, a new matrix operation called scalar multiplication. And what that means is you take a scalar or a number and multiply it by a matrix. And what that does is you take that number on the outside and multiply it individually by each one of the entries in the matrix. So for example here, if I had 100 here, I multiply each of these by 100 and they keep their same positions, nothing moves or anything. If this were 50, I would multiply each one of these by 50. If it were negative a million, I would multiply each one of these entries by negative a million. That's just the way scalar multiplication is, and we notice that it doesn't matter which side, it doesn't matter how we do this multiplication. It could be 100a or 100 times a. They mean exactly the same thing, and it works as long as we have one of them, the things that we're multiplying, one of the factors is a matrix and the other is a plain old number. So anyway, that's scalar multiplication, and with matrix addition, subtraction, and scalar multiplication, that's kind of all we need for the starting point of image processing, which we're going to start discussing in the next few videos.